this point, I would like to go ahead and welcome Arun. I'm going to bring Arun on right now. Arun is a senior technical support engineer with Palo Alto Networks, and Arun is going to be going ahead and speaking to us about advanced data plane troubleshooting. Arun, are you there?
Hi, Charles.
Hello. And with that, I will turn the show over to you. It's all yours. Let me know when you'd like to take a break in a little bit.
All right. Thank you, Charles. Thank you very much.
And if
Hi,
you could
everyone.
bring your volume up a little bit, that would be helpful, please.
Say that again.
If you could be a little bit louder, please.
Oh, okay. Can you hear me okay now?
Better. Thank you very much.
All right. Let me share my screen here. Hi, everyone. My name is Arun. I work for Palo Alto Networks as a tech support engineer. And today we're going to talk about advanced data plane troubleshooting. So I hope, Charles, you can see my screen. Everything is fine so that I can begin.
Yep, everything looks great.
All right, moving on. Okay, so today's agenda is we're gonna talk about how we can actually collect the basic data on the Palo Alto firewall when we are trying to troubleshoot some problem, how different troubleshooting methodology can help us to achieve or what we desire to troubleshoot, how different counters can help us, how PCAPs and packet diagnostics can be leveraged to troubleshoot any problem on the Palo Alto firewalls. We can have a lot of flexibility in logging, in collecting data. We have advanced tools to diagnose any of the problems which we are facing on the Palo Alto devices. So we're gonna also be covering about data plane issues, how data plane can impact the any of the problem. We're gonna talk about how high CPU affect production environment and how the traffic is affected. We're gonna also talk about high packet buffer and packet descriptor. So let's begin by looking at the logging and how we can leverage to troubleshoot any problem we are facing on the Palo Alto firewalls. So when we are facing the problem, how should we start collecting the basic data? So let's say we are facing a problem and we don't know where to begin. So what exactly we need to do to troubleshoot the problem? So the first point is looking at the logs, which is under the monitor tab on the firewall. And Palo Alto logging is really powerful, and most of the issues, I would say about 80% of the issues we can just understand and troubleshoot just by looking at the logs. It's so powerful. Okay, so let's say we are facing a problem. There's some communication problem, and we cannot access a resource behind the firewall. So the first thing we're going to be looking at the traffic logs. And the traffic log has a lot of flexibility. We can have a lot of filters just to see what exactly happened to the traffic and why we are not able to access the resource, or is there any drop? I mean, what exactly firewall is doing to that traffic. So most common filters you can use just to filter the traffic is always look for the source address and the destination address we are trying to work on. As you can see here on my screen here, we have a lot of options. So all these options which are here highlighted in yellow, all the columns, you can have filter for each. So in this case, we are using for source and destination. In the similar way, you can have a filter for zone, for source user, to the port, application, action, which rule is being hit, what is the session end reason. And there's a lot of flexibility. So later I'll show you on the lab how we can customize these columns and leverage the logging on the firewall. So always begin with looking at the source and the destination, and look for the zone, which is in ingress zone from which the source is hitting the firewall, and compare it with the egress zone, which is the zone we are trying to get to. What is the port we are hitting? What application is it? What is the action to that traffic? Is it allow, denied? Which rule is being hit? So all these information can be leveraged so that we can easily troubleshoot the issue, or at least have a clear picture that what exactly is happening to the traffic. We have configured everything fine, but it's not working. So why it's not working? Logging is the first place where you begin. So these are the common questions you ask yourself. Is there any traffic at all? So do we see anything coming on the firewall? What are the high level processing results? So are we hitting, is the user intended? We should see the traffic from the intended user. Which application is being used? Are we hitting the correct security rules? If yes, what is the action on that security rule? Okay, if the session is ending, being terminated, what is the session end reason? So as you can see in this snippet over here, we could have multiple session end reasons. So few of them are listed. It could be reset from client, reset from server. It could be threat related. It could be a normal TCP session termination with a TCP fin. So all these details you can easily look into the monitor logs of the firewall. Okay, to have a better picture that what exactly is happening, we have a magnifying glass next to each log which is generated by the firewall. You can just click on it. I'll show you again. So here, this is the magnifying glass. Once you click on it, you will see this window. So this window will give you a session ID, what is the action, what is the source, what is the application, which rule we are hitting, what is the session end reason. It will also give you a user info, source IP address, the port which is user is using, the zone from which user is coming to the firewall, the interface, which interface is that zone part of. So in this case, inside is mapped to Ethernet 1/2. What is the NAT IP? What is the NAT port? For the destination, we can have destination IP, the interesting port, which is 80 in this case, the zone, over here it's outside, and what is the egress interface the firewall is will be using to route the traffic. So at this point over here, the firewall actually looks for the egress interface, so to route the traffic out. Then we can have some details at the packet level, that how many bytes the firewall has seen, how many bytes received, how many bytes sent out, how many packets we have seen. So there's a lot of info here, and you can leverage all these options just to understand what exactly is happening with the traffic. Okay, so this is the general overview of any of the traffic that's hitting the firewall. We can have a basic info there. What's the session ID, what's the action, and things like that. So if you see for some reason, there's a application field in the monitor logs, you could see we don't see the application name, or we can see the status is incomplete. So that means the firewall has not seen any packets. Sometimes there could be insufficient data. So for the firewall to identify any application, we should see few packets back and forth. So it just does not happen on the first packet which reaches the firewall. it gets to see few packets before identifying the application correctly. So we have a signature based app IDs where a lot of complexity is there, like port numbers, protocol numbers, things like that. And that's how the signatures are being created and included when the traffic is identified. So it could be unknown TCP, UDP, and P2P. So the reason for that is we don't have any matching app ID signatures. So if we don't have it, this is how we gonna classify it. And let's say if we have a new, something new, which firewall doesn't know about it, or something different, or we can say a customized application, which is not using standard port, that will, the information about it will be a new or different, or so for that we need to have a content update, or we may have to change the signatures just to identify it correctly. So for the app ID, we have a lot of flexibility there. We can customize it. We can use the default content. So there are a lot of options. It depends on the requirement and what we want to achieve. Okay, so before an FQDN object can function properly as a policy rule element, the DNS query response received by the client must align with the DNS query response received by the firewall. If your internal clients are not using the same server that the firewall is configured to use, failure of the traffic initiated by the client to match to a rule that uses an FQDN object becomes increasingly likely. Every 30 minutes, the firewall will perform an FQDN refresh. This refresh consists of a name server lookup to the DNS server that is specified under setup services page of the web interface. The firewall maps up to 10 IP addresses to each FQDN object. So generally, you should use FQDN objects only when you cannot use an IP address, because the resolution will happen in the background and that delays things. So in case of using FQDN, there's a little delay because you need to resolve all those FQDN to an IP address. However, FQDN objects can be useful to help control services that do not relate to web browsing, such as FTP, SSH, or any other non-HTTPS service. You should never use an FQDN object as a part of a URL filtering policy. If the FQDN object resolves to an IPv6 address, you will need to enable IPv6 firewall on the setup services page of the web interface. When traffic is matching to an unexpected policy, use the session details of the traffic logs or the session browser to discover the addressing details of the session and the policy is matched. If the traffic is matching to a rule that is not configured to create traffic log entries, consider getting a packet capture. So these are few of the things which you should ask yourself. Okay, so the rule is configured. Is the correct rule being hit? Are we using FQDN address object? So there's one thing about FQDN address object is, let's say if you have a dynamic mapping and one FQDN is resolving to different IP addresses. So in those cases, a little delay is expected because the firewall is actually, trying to resolve it in the background. So then you should look for the NAT policies. Are we hitting the correct NAT policy associated with that security rule? Is the traffic going on the wrong port? Like for the web browsing, we have 443. It could be 80. And for management consoles, it could be 8080. So there is no standard for it, but we can customize the ports. Like it could be 8080, 8087, etc. And does the matching rule also have enable application default, which is once you call it in a security policy, it's gonna use the default ports for the application detection. So uh, for example, HTTP is associated with port 80 TCP. Okay, so this is the section where you can actually add your application default. So let me change it, just a minute. Okay, so application default is the default option for the firewall. So selection of this option does not stop the firewall from checking for all application on all ports. The logic works by first identify the application. So the firewall needs to see few packets back and forth. Once the application is identified, then the firewall will allow the application only if it's been detected on a standard port. If the port is not standard, the firewall will have difficulties detecting it correctly. So the port is used as one of the criteria in the signature mapping. If your server uses only a subset of the standard ports, for example, if your SMTP server uses only port 587 and the SMTP application has standard ports defined as 25 and 587, uh, 25 is the TCP, 25 is SMTP standard port. So you can create a new custom service. So we can have a customized application where we just explicitly tell it that okay, instead of just using 25, also start using 587. So that way that customized application will be seen in the monitor logs. So over here, this is the example. Let's say the application is allowed, but the port is not matching. So it will not be matched. And if we have a non-allowed application, but the standard port, it's not gonna match. So we can say, okay, allowed application is HTTP plus non-standard port is 90. It's not gonna match because for HTTP, the port will be 80. And for the non-allowed application, so let's say the port over here is 80, but the application is FTP. So that will also not be matched because it is not correctly mapped with the port. Moving on. So over here, there's a snippet under object application. So we can see if you try to view any of the application under objects, it will show you all the standard ports which are used by that application. So for Active Directory, these are the range of ports, LDAP, MS Exchange. So we have a lot of applications. You can also use Applipedia. That's the app we have, applipedia.com. And over there, you can see what apps we have and how we categorize it, for what we use that app. So a lot of options there. Moving on. So when we see the traffic is hitting the firewall and something is not working, so what we need to do in that case? So the first thing, we look for the monitor log. We're gonna see number of hits, and we're gonna verify the rule. Okay, we are hitting the correct rule. There's a correct net policy. Then we click on the magnifying glass to get more information about the session ID and other information, source zone, source user, destination port, things like that. And if for some reason we are not hitting any of the rule, what we can do is we can hit a default rule which is there at the bottom of all the security policies. So by default, intra zone is there, which is configured with the allow action, and then we have a interzone, which is a default deny. So we can reset the counters on the security policy and then again send the traffic and refresh the counters and see, are we getting any increments on that security policy? If yes, which security policy it is. And let's say you have thousands of policies and you are not able to track down the correct security policy. In that case, you can create a customized test policy and then you can just move it to the top. This is just for troubleshooting if we are not able to identify a security policy correctly. So we can have a specific policy, depend on the traffic type, and move it on top just to see are we getting any hits. So we don't want you to take any packet captures at this point, because we just want to keep it simple and just try to identify are we getting any traffic. So this is one of the way. Okay, if something is not expected, what do you have to check in the traffic logs? The source address, destination addresses, ports, NAT. Are we using FQDN? Then we have to examine those FQDN address objects. Is there any policy-based forwarding for the routing? We can have a good test command here. Let's say you are trying to do a lookup and you want to know which egress interface or which route the firewall is going to use. So we can this command test routing lookup virtual router name, IP, and the destination IP address over here. So it will exactly print out in the CLI that which egress interface it's going to use. Look for the applications, services. Service is just having a port number assigned, and application could be any application, your customized or the well-known. User, if you have a user-based policy, look for the mapping. So these are the two commands you can use for the mapping on the firewall. So show user, IP user mapping all. And if you have group-based security policies, you can run this command, show user group mapping, state all, which will tell you the group mapping associated with that user based on your security policy. If everything is correct up to the user, let's go into more detailed functionality, which is a packet count. So we're going to examine client to server and server to client. So there are always two flows. One that comes on the ingress zone. So that's client to server traffic. And another one is server to client, which is part of egress. And up to this point, we see, okay, we see the packet counts in both the directions, and we still not able to figure out what's going on. There could be a asymmetric routing issues. The traffic is not taking the same path, going out and coming back in. So that could cause a lot of issues on the firewall because it's a stateful device. Then look for the rules which are matching, which policies we are hitting, which security rule is being used. If you have any profiles, examine all the profiles. Which NAT rule is being hit? Do we have quality of service mapped to that traffic? If yes, evaluate all those QoS policies and see if they are causing any issues. If you are doing a URL filtering, look for the URL category that is being used. What is the cache? Are you using any customized pages? So look for all that info. Are we doing decryption to that traffic? So if the decryption is in place, we have to check the decryption logs, which is in the same place as the monitor logs. So, and if you want to see the decryption happening in the CLI, you can use show session all filter SSL decrypt yes. And session browser is also another utility which you can use to examine live traffic. So if there's a live traffic, you will see that session information in the session browser. That's also available under monitor logs. And in the end, we're gonna look at the tracker stage, why the session end. So I'll quickly show you on the firewall how these things look like. Okay, so this is the firewall GUI. So this is the monitor tab here, logs, traffic. So right now on this firewall, we are seeing live traffic. So as you can see, your time is 14:34, which is the current time in my time zone. And the date is 3rd December. And this is one of the session where the zone is trust, untrust. This is the source IP and trying to talk to 111. That's Cloudflare DNS. So if you want to put any of the filter, you just have to click it. So it's kind of hyperlink. You just click it and we have a filter there. And the firewall automatically put the Boolean operator and or, and you can always change it as per your requirement or and whatever you want to use over here. If you want to filter for port, it's going to put for port. We also have a builder here. Okay, so you can use a builder to put your customized filter to see the traffic, interested traffic, because there could be 1,000 of logs here, and it's not easy to identify session just by scrolling or going to the next page. What you have to do, you have to leverage the filter. This is a very powerful tool on the firewall, and it can help you, mitigate the problem. So this is the magnifying glass I was talking about earlier. So you can click on any of the magnifying glass associated with that session. You can maximize it from here, and then you can look for the session ID. Session ID, what application we are trying to use, what rule we are hitting. You will see the time. So the logging happens normally at the end of the session, but just for troubleshooting, you can do it at the start of the session, but that's not normal. It's just for troubleshooting. Okay. This is the start time of session. This is the receive time. This is the source IP, port the client is using, zone. This is your ingress zone, NAT IP, NAT port. And for the destination, we are trying to go to this IP on port 53, zone untrust, interface 1/2. This is port 53. Okay. If decryption is happening here, you will see a check mark here for the decryption. So that way, the firewall is decrypting some traffic. And then if we gonna see the stats, which is here. So this is the byte received. This is the byte sent out. So this is what we have received. It could be in both the directions, because ingress and egress, we can receive from both the interfaces and transmit out of both the interfaces. Okay, these are the byte packets. Normally we just focus on byte sent and bytes received. This way we know we are sending something out. And yeah, that's pretty much it. So on the security policy, this is one of the security policy configured on this firewall. And over here under actions, so this log at session end, it's enabled by default, because we don't want to log every session at the beginning. There will be a lot of logs. So if you're trying to troubleshoot something, you can enable this. Otherwise, just keep it disabled. So when the session ends, it will generate a log here. So that way, okay, what exactly happened that traffic. Okay. So these are traffic logs. In the similar way, we can have threat logs. So right now it's empty because I'm not using it on this box. And we have, log categories for with each feature. So global protect, hip match, decryption logs will show up over here. And I was talking about this session browser earlier. So whatever you see over here, these are the live sessions. It's not the historical data. This is what going through the firewall right now. So this is a live session information. So when you click on this plus icon here, it will give you all the information, just like we check in the traffic logs. So this is the same information here, but this is for the live traffic. Okay.